select the appropriate rating of the component. We have to select the appropriate thickness of the piping. Okay, and also the piping material. We have to select the appropriate rating of the component. We have to select the appropriate thickness of the piping. Okay, and also the piping material engineer in few companies assist for taking of the piping MTO, or in few companies there is a separate team for the piping MTO. Those piping MTO designers or the engineers will take out the quantities of the piping components like pipe, valve, fittings from the PNID, and all this data will be consolidated by a piping material engineer in different softwares. Okay, so in the cost estimation phase, we do not have so much of time, as well as the client does not give us so much of money, you know. So we cannot model each and every line in a software E3D or SP3D. We do not have that much time. So it is just based on the PNID, we take out the quantities, and then it is summarized in different formats, either in Excel, or many companies have different their own softwares. So we can feed data in that software and take out the whole consolidated MTO. And output will be carbon steel pipe 1 inch, 1 kilometer. Carbon steel pipe 2 inch, let's say 500 meter. I'm just giving you the sample case. Or the gate wall 1 inch, 100 quantities. Wall 2 inch, 50 quantities. So all these quantities will be then given to a procurement department. So the procurement department knows price of each and every component. If not, then they will reach to the different vendors in the market and take out the price. Then this whole price of all the MTO will be consolidated, which will be called as a piping cost from the piping department. And similarly, such cost will be developed by the different engineering departments like the mechanical instrumentation, chemical, every whatever they want to buy, or the civil, which is a major cost, or mechanical also the equipments, and that cost will be given to a client. So this is how a piping material engineer is involved in the bid phase. When you get an actual project, then you have to design the project. It means you have to develop the models in the SP3D or the E3D. For that, now everybody knows, many of you are the piping engineer. So you model it in a E3D. But how do you model? For that you require some input. So that input is given by a piping material engineer in terms of a pipe classes, in terms of the components. Yeah, and then it will be cataloged in the E3D by the E3D admin. Okay, and then further steps. I will not go in too much of detail because we don't have that much time to discuss everything. So what are the main role of a piping material engineer? It is design. In design phase, what he does, the most important activity to perform the pipe wall thickness calculation. Second, to prepare the PMS, piping material specification, for process and utility services. We will see the example of this PMS document. To prepare VMS, wall material specification. Okay. And what are the other design activities done by the piping material engineer? To prepare the line list. Okay. So in the line, in a project, let's say we have 5,000 lines. So a line contains different data, like a line number, size, fluid code, pipe class, insulation type, insulation thickness, pipe routing from, to, its design pressure, design temperature, operating temperature, sometimes the stress analysis number, stress analysis category. So all this data is consolidated in one document and given to a site for the easy reference, and that document is called as a piping list. So it is a responsibility of piping material engineer. Why? Obviously, it depends from company to company. But as a piping material engineer, he will consolidate all the data from the PNIDs, as well as the lines which are extra added into E3D. Sometimes they are not PNID because of the utility lines. Later on, they will come on PNID also at the IFC stage. So yeah, and this is also mainly done through different softwares in different companies, or you can maintain the line list in Excel also. To prepare the list of piping specialty items like the stream traps, strainer, hoses, etc. So generally the components like the pipe, elbow, reducer, T, gasket, wall, bolt, we call walls, we call all these components as a standard piping components. Other than the other than this, we have few components like the stream trap, strainer, hoses, or a different layout special parts. Like funnel or the bird mesh. These are also included in the piping spec, but they called as a special items, and sometimes it is required to prepare the special part index list, which is used by a site because for the special part, each special part you have to create one data sheet which gives details of that component. It is called as a special part document. So then it is easier for the client and the site people to refer how, if they want to see the details of that component, then they will easily go to the doc ID and open the document. I will not be able to show you the special part list at this moment. Otherwise, I would have showed you. To prepare the data sheet for the special piping specialty items, like I told you, for the stream trap, it is not a standard component. We have to prepare the data sheets. In the data sheet of the stream trap, we will mention that this stream trap is used for which service, like majorly for the steam. Then what is the design pressure and design temperature of the fluid? Then what is the flow? What is the delta P differential pressure? Accordingly, vendor will select the suitable type also. So all these details are mentioned in these data sheets. To perform the line blank thickness calculation. So a line blank, many of you know that spectacle blind we called. Sometimes we call it spectacle blind. Sometimes we call it as a figure eight, or sometimes we call it as paddle blank, paddle spacer. So these are actually, it is a standard item, but this is a standard item till 24 inch only. We have different standards mentioned for this. So it is a ASME B 16.48 standard. So in that standard, the thickness of the spectacle blind, it mentioned till 24 inch only. So if you want to use a spectacle blind above 24 inch, then what should be the dimension of that spectacle blind? What should be the thickness of the spectacle blind? So actually it has to be calculated as per ASME B31.3. Yeah. And that's why we have to, as a piping material engineer, we have to do the calculations to arrive at the thickness of this line blank. Or sometimes when the complete piping is erected at a site, we have to do a testing also. So for the testing also, sometimes we have to block the end of the pipe and to do a testing. So for that, we cannot use a blind flange every time. So there also sometimes we use a line blanks, and depending on client, it can be just cut from the sufficient thickness of the plate and weld it there. But then what is the sufficient thickness of the plate? That also we as a piping material engineer have to calculate to perform the reinforcement pad calculation. Yeah. So this terminology is like everybody knows. I mean, obviously we will also see this part when we will see the actual slides of the piping components. So when you want to take the branch calculation, maybe what I would also like to prefer to, yeah. So this is a branch calculation, and to this we have to sometimes weld this additional pad, this material, which is called as reinforcement pad. So every time we do not use this pad. Sometimes it is just hold to this main pipe and weld this branch pipe. We don't require this every time. So whether this is required or not, it is done by the calculation by the piping material engineer. The formulas and all the basis is given in standard ASME B31.3. To develop technical supply conditions or requirement of various piping material and to make technical recommendation. As I told you, first we will prepare the piping specification. That piping specification will be used by the 3D modeling softwares. Then we take out the MTO, consolidate all the MTO. It means at the end we will decide how much quantity we want to order to construct this plant. And then we will go to the different vendors and ask them we want this component. For example, we want 10,000 kilometer of the pipe. Then we will go to the vendor and we will tell them that we want this size and this much length. Okay, but actually this is not sufficient. In addition to quantity, we also have to tell them the exact specification. Obviously, like other than materials, what are the different testing needs to be carried out? Okay, there are so many different requirements, and these requirements are mentioned in different documents, which is generally called as the enclosure. So for each component, for the pipe, we create a different enclosure. It sometimes calls a technical notes or the enclosure for the pipes. In the document, you will see different many technical requirements are given, like the if it's a carbon steel, then that carbon steel material shall be normalized, you know, or stainless steel solution annealed. Wherever you want PWHT, you will specify we want PWHT, radiography, all these requirements are given. So that vendor will comply to all those requirements. So these documents also we have to prepare as a piping material engineer. Then as I told you, the bill of material, we have to prepare the piping bill of material, to arrive at the total consolidated quality quantities which we want to give it to vendor and to the client also. To control the piping item quantity, monitor the surplus and shortage of the piping items. It means um, everybody knows that our projects runs for at least 1 year, at least. So let us say our project in the engineering phase it runs for the 2 years. Okay, then we do not procure the item after the 2 years. From the day one, we will start procuring the items. Okay, but let us say in the first 6 months, I have procured some, let us say 10,000 kilometer of the pipe. Okay, and later on during the phase, I know that okay, actually I don't require 10,000. I want only 7,000 kilometer of the pipe. Then that 3,000 kilometer is the extra pipe. But then if I do not require that extra pipe, I should not pay for that also. So then we have to convey it to vendor that okay, initially we have asked you for the 10,000 kilometer of the pipe. Now our latest quantity is 7,000 kilometer. Can you please reduce that quantity? Or sometimes we want the extra material also. No, we just say that we want 100 walls. But later on, there the addition of the walls, then we require maybe 125 walls. Then we will say, okay, we want 25 extra walls. So this addition and deletion of the quantity also we have to track as a piping material engineer. Sometimes in few companies, this procurement is in a scope of there are different engineers, procurement engineers given for this task for the quantities also. Yeah, but many of the organization it is like piping material engineer will send, or he will also control the quantities, and the procurement engineer will only coordinate with the vendors for the commercial purpose. For the technical purpose, a piping material engineer is responsible. Yeah. So when I say for the technical purpose, it means, let us say I have asked for the 10-inch pipe of let us say 10 mm thickness. Okay. Now vendor is saying instead of 10 mm, he can give 9.5 mm of the thickness. So actually this is a deviation to our requirement. Then as a piping material engineer, it is my duty to check whether that 9.5 mm is suitable or not. Yeah. So this is called as a technical clarification or the technical decisions. Once I give the clarification that okay, whatever a vendor is offering is acceptable to me from technical point of view, then the procurement engineer will do the commercial negotiations. Okay, then what is your price? Can we reduce the price? With different vendors, they will talk. Okay. So all this is the part of the procurement. So in procurement, what we do, first we prepare the material requisition for getting quotations. Yeah. So I will try to explain you this with some analogy. Let us say you want to buy a mobile. Okay. Then let us say we are not buying from the shop. We are not buying it online. We are buying it from the shop. Then we will go to a shop. Do we say that we please give me a mobile? We don't say we just give mobile. Okay. We tell them the exact specification. Like first we'll tell them whether we want to go for the Android or the Apple. Okay. That is operating system. Then after going for the Android, we have different companies. Okay. Samsung, MI, you know, Nokia and things. So we tell him I want a mobile of this company. Then he will again filter out what should be the screen size. Okay. What should be the RAM? What should be the operating system? What should be the then it has a camera. What should be the megapixel of the camera? You know, or in addition to that, you will say I want battery back of so many hours or battery of so many thousand mAh. So we give specification to the vendor when we want to buy a mobile. Okay, in similar fashion, when we want to buy a component which is required in a plant to construct, and when we are buying it from the vendor, we have to give this all the different requirements to the vendor. Requirements in the sense the specification. So all these specifications are tabulated in one document which are called as the MR, material requisition. Then we give this document to different vendors. Okay. Now, if you want to buy a mobile, will you go to a shop of an automobile or um, will you go to the clothing shops? No, you will not go to clothes. If you want to buy a mobile, you will go to the shop of the mobile. If you want to buy a clothes, you will go to the malls to buy clothes. Similarly, in piping, over a plant, if you see what are different type of components. There are pipes, elbow, reducers, tees, then gasket, bolt, different walls, and each vendor does not manufacture all these items. You have different vendor for different category. So let us say the pipe manufacturer generally he will not manufacture the wall, you know, or the gasket manufacturer he will not manufacture the pipes. Even in the pipes, few vendors will only manufacture the carbon steel pipe. Few vendors will manufacture only the stainless steel pipe. So depending on the category also I have to select the different vendors. Yeah. So there is a vendor list given by the client, and as APC consultant we also give our recommendation to the client that these are the vendors which are known to me. Okay, like we say, if we want to buy something, then obviously we have some favorite shops which are known to us. Then we some a Samsung mobile, I have a MI mobile. Okay, then you as a customer have a choice to decide. Even though your requirement is Samsung, vendor is offering you MI. Is that MI mobile suitable for you or not? Similarly, the vendor will give a deviation and we will decide whether it is suitable for us or not. So all this process is called as a review the vendor offers. Okay. Then as I told you, there will be some deviations. Every time vendor will not give what we want. Because vendor also have his own standards. So in such case, we have to do the technical discussions with the vendors. And at the end, we will prepare one document which is called as a TBE. So as I told you, let us say when you want to buy a mobile, yeah, you will not go to a single shop. Let's say you will go to 5 different shops. You will ask for the same mobile, and everybody will give you the different prices. And which is the best price or the vendor which gives the best offer, you will select that vendor. Similarly, we do it here. We do not go for the single vendor. Yeah. And also it is not fair to select a single vendor. It is always recommended to at least have 3 vendors. So you can compare the prices and everything. So we should have at least 3 vendors. So this inquiry is sent to at least 3 vendors and then it's evaluated. Yeah. What are the other tasks of the piping material engineer? Coordination with other engineering departments, piping modeling. Yeah. So help 3D administrator in PMS creation in 3D software like PDS, PDMS. Nowadays it is called as E3D or the SP3D. So we as a piping material engineer, we have produced one document as a PDF document. But how it shall be used by layout engineers? It has to be transferred to the software. Then we always, when we are using a software in a company, we have different links. The software which we use for the piping material specification, we can transfer the data from this software to E3D by single click. Yeah. And then piping stress, thickness change as per the stress requirement. So as I told you, the role of the piping stress engineer is to check the stresses developed in a pipe. Sometimes it is required to change the layout of the pipe to reduce the stresses, and sometimes we have to increase the thickness of the pipe. Okay, then the stress engineer will say, okay, increase the thickness of this pipe or this component. Then we will increase the thickness of that component. Then process is the most is a department with which a piping material engineer has a very vast and larger discussions, because process engineer is responsible for the PNIDs. Process engineer is responsible for the fluid list, and to prepare the piping material specification, fluid list is an input, because in the fluid list the process engineer gives the basic material, whether it is carbon steel or the stainless steel, and the design pressure and temperature, and obviously based on that we prepare our pipe classes and the corrosion allowance. Instrumentation, we have different instruments which we use in our piping whole plant. Okay, let us say pressure indicator. So what is the end connection of that pressure indicator? As a piping, we have to give the suitable end to that pressure indicator so that it can be get connected. Or sometimes many of the times the instruments are the threaded, male threaded, so we have to give the suitable female threaded components to attach these instrument items. With the mechanical also, we have sometimes the coordination. Mainly the coordination with the mechanical department is to decide the nozzle, especially 24-inch and above, because I will not go at this moment too much deep. The flanges which we use in the piping, they are used as per the ASME B16.5 standard. Above 24-inch, we use ASME B16.47 standard. So in ASME B16.47, we have two different options, Series A or Series B. So ideally, if the piping is going to connect with that equipment, both the flange have the same series or the same type, I will say. That's why sometimes we discuss with the mechanical department. I would not go through all these slides at this moment because I want to explain you the maybe I will go with the piping components very quickly.
Okay.
Yeah. So I know all of you are the piping engineers, so I will not go into very much basics of this. So what are the different piping components? They are the pipe, fitting, flanges, gasket, bolt nuts, and walls. Okay. So in pipes, we have different end connections. Like these are the plain ends, which are generally used for the socket weld connections. We have this beveled end. We have these male threaded ends. Okay. And then fittings. So there are different codes and standards which are applicable to each and every component. So fittings are generally as per the ASME B16.9 for the butt welded, B16.5 for the flange, and MSS SP75 for the sizes bigger than 48 inch. Okay. Then we have this 90-45 degree elbow, 90 degree elbow. In there also we have long radius, short radius, then T's, cross, cap, reducers, stub ends, couplings. Yeah. So reducer looks like this, eccentric and concentric. Then we have different T's. We have branch outlet, welded, threaded, socket, depending on the connection of the pipe. So if for a branch pipe is plain end, then we use socket. If a branch pipe is welded, then we go for the welded. And if a branch pipe is threaded, then we go for the threaded. Okay. Then we have the flanges. Flanges are designed as per standard ASME B16.5. Okay. So the main purpose of flange is to connect to different pipes or the walls. And then also we have different types: weld leg flange, slip-on flange, socket weld flange. So if you see the difference in slip-on and socket weld is here. Here it is just a hole, but here if you see some slot is there to restrict the coming pipe. Then lap joint flange, threaded flange because threads are here, blind flange. I don't know if you know this point or not. When the socket weld flange is welded with a pipe, always there is some small gap is here.
Yes.
So if you insert pipe here, the pipe will not touch this part. Some part is always kept. Sometimes I think it is 1.6 or 2 mm of the gap is kept here. Okay. Then we have the flange facings. Here we have the flat face flange. Here you can see some raised face, and this is the ring type joint, and this is tongue and groove. Yeah. So generally the type which is used is a raised face type, but in the higher rating like 1500 and 2500 we go for the RTG flanges for the better sealing connection. Then we have different gaskets used. Okay. I did not go through this much detail because everybody knows these components. Maybe I would like to show you the document which might be interesting for everyone. Is a piping material specification. So can I start with this document, piping material specification?
Yes, please.
My idea is to explain you at least one piping class. What are the content of the piping class and its components. Yeah. Do you have any point to say at this moment? Maybe obvious. If there are any question and answers, we will take in last 15 to 20 minutes. But do you have any point at this moment with this document? So this whole document is a piping material specification, which is short form is PMS. Okay. So it starts with the index, like any document. It lists the number of pipe classes used in a project. Then it gives its basic description of that pipe class, that this is class 150 pipe class. What is the corrosion allowance? It is 1.5 mm. Any special requirement, which is a basic material, carbon steel or the stainless steel, and for which services it is used. Okay. So if you see here the carbon steel material is used for the very basic, the fluids like the steam and condensate, utility lines like plant air, nitrogen, non-lethal process, which are the non-corrosive fluids. So for that carbon steel is used. But here the corrosion inhibitors, these are the corrosive fluids. For that they have used the stainless steel material. Everybody knows that stainless steel material is used, has higher corrosion resistance properties than carbon steel. So we will at least see one pipe class, how it is. I will not say how it is prepared, but what are the contents of the pipe class. Okay. So it's a piping class A1A. This can be any designation depending on the client and the projects. Then what is its rating? It is class 150. We have different classes like class 150, class 300, class 600. What does a rating defines? Anybody can tell me what is a rating?
The rating is 150.
What it signifies?
So rating is 150, I think, no?
So rating defines the pressure taking ability of that component. Majorly rating is defined for the flanges because it is dependent on the rating, and for the pipe it is depending on the thickness. So as a process engineer, let us say this pipe class is used for these many services. So for each service, the pressure, design pressure and design temperature are given by the process engineer. Based on that and standard ASME B16.5, we will check what is the rating, whether it is class 150 or class 300 or 600. As the number increases, the pressure sustaining capacity increases. So lowest pipe class available is a class 150. Obviously, we also have class 125 or class 75 for the ductile iron, but generally it is not used. As a carbon steel and stainless steel, class 150 is the lowest rating. What is the base material? Carbon steel. It is also given by the process. What should be the base material? Because as a process, they know the corrosive property of the fluid, and also this base material comes from the licensor, because licensor knows, he has developed his technology, so he knows that what are the properties of that fluid and which material is suitable. Okay. Then corrosion allowance 1.5 mm. We will not see in detail what is the corrosion allowance, how it is used, but the basic concept is that over the period, the pipe gets corroded due to the fluid, and it should not, because of the corrosion, the thickness of the pipe gets reduced, and it should not get reduced so that the pipe will get punctured. And for this, we add some extra thickness to the pipe. Then this is a pressure temperature rating chart. Yeah, it simply means till 38 degrees Celsius, this piping class can sustain a pressure of 20.03 kg per cm square gauge pressure. Okay, the fluid flowing through, it will have different temperatures. Let us say if you have a temperature of the 200 degrees Celsius, then we will interpolate these two different values. At 149 it is 16.17 kg per cm square. At 204 degrees Celsius it is 14.06 kg per cm square. So at 200 degrees Celsius it might be more than this and less than this. So it will be something around maybe 14.5. Okay, so let us say at 200 degrees Celsius, this pipe class is suitable till 14.5 kg per cm square pressure. It can handle a fluid with that pressure. Okay, then what are the content of the pipe class? So it shows the details of all the piping components, like the pipe. So we will go by one row. So here if you see they have given pipe, lower size 1/2 inch to 3/4 inch. Now the pipe is yeah, before this I would like to show you this PPT. Yeah. So there are two different things. One is a code and another is standard. Okay. So standards are the document prepared by professional societies or committees which are believed to be efficient engineering practices and which contain mandatory requirements. Additional requirement to the code. So these standards. So here if you see for the pipe, for the pipe, what is the standard mentioned? What is the dimensional standard? ASME B36.10. So this is one document. In this document, you will see the dimensions of the pipe. You will see what is the thickness of the pipe. Okay. And we specify the material as per ASTM A106 grade B. Then if you open this is also one document. If you open this document, you will see so many different requirements are given in this document. So vendor has to comply all these requirements. Maybe I will show you one case. ASTM A106 PDF. Yeah. So this is just a designation or some name is given to that material, because when you go to vendor and ask, you can ask, I want carbon steel pipe. You will specifically tell them, okay, this is the type, this is how it is called. So for each type, there is some namings are given by ASTM committee, and that's why it's obvious. For metal is B, non-metallic is non-ferrous is B. That we will see later on. So if you see this standard, what it says, standard specification for seamless carbon steel pipe for high temperature service. Okay, and if you see the scope, this specification covers seamless carbon steel pipe. So when we say my pipe is as per ASTM A106, then always it is a seamless pipe and not a welded pipe. Okay. This standard covered which sizes? From 1/8 inch to 48 inch. Okay. What are the, and here you see it is not only 106, it is a grade B. Then what do you mean by grade B? Details are given in this standard. So if you see the chemical requirements, grade A, grade B, grade C. The major difference is in a carbon percentage. In grade A, it is carbon percentage is only 0.25%. In grade B, it is increased 0.30. In grade C, it is more increased 0.35%. And as the carbon percentage increases, the mechanical strength of that material increases. So we can say that ASTM A106 grade C has a higher mechanical properties than grade A material. Okay. So yeah, as I told you, if you see it here, tensile requirement. So grade C has 70,000 psi and grade A has 48,000 psi. So C has a more tensile strength than A because it has a more carbon percentage.
Sir, 106M is something.
Then generally what this standard specifies, if you see here,
We are not able to hear you. It is hanged.
yeah, sorry, I was, my Teams was closed suddenly.
Okay.
Yeah, okay. So, yeah, so this standard, I will only show you one standard or only one ASTM code. So it gives you the scope, which sizes are generally covered, and then ordering information. So if you want to order this material, then how it shall be ordered? It should be ordered with the quantity, like this is pipe. So how much kilometer or the meter of the pipe, name of the material, like A106. Then you want to show the grade also, grade A, B, or the C. Manufacturer, how to finish. Then what is the size? Which size of the pipe you want? The length. Yeah. And then when you say I want grade C pipe, then when so when you say grade, when you specify ASTM A106 grade C, then vendor has to comply with all this requirement, all this chemical composition, and that is the advantage of codes and standard. So in any part of world, if you ask for the ASTM A106 pipe, vendor has to follow this single document, and that is the advantage of standard because it standardizes the process everywhere you go. Yeah, and it gives you some requirements of the heat treatment, chemical composition as we have seen, then the tensile requirement, then whatever the material is produced by the vendor, it should have at least this much of the tensile strength. Okay. Then he will have to do the hydrostatic test as per this requirement. Yeah. Also Also, variation in the outside diameter. It means, for example, let us say 4-inch pipe. The outside diameter of 4-inch pipe is 114.3 mm. Okay. But as we are manufacturing the pipe by different process, you cannot manufacture a pipe with exact 114.3 mm of the thickness. 114.3 mm of the outside diameter. For sure, there will be little bits of the variation. Okay. Then how much is a permissible variation? Over 1.6. It means vendor can provide a pipe of 114.3. So I am referring to this value now. Over 4 to 8 inches. Okay. Over 1.6 mm. So what is the outside diameter of 4-inch pipe? 114.3. But even if we manufacture the pipe till 115.9 mm of the OD, it is acceptable to the inspector. Or under 0.8, that is 114.3 minus 0.8, 113.5. So within this range, if there is an outside diameter, then the inspector can accept that pipe. If it is other than this value, inspector has the authority to reject that pipe. Yeah. So all this requirement as a piping material engineer, you cannot give every time because there are so many different requirements. That is why they have prepared one document, and in the piping spec, you just give the reference of this material. Vendor has to follow all the requirement given in this standard. Yeah. So coming back to our PMS topic, is a pipe from 1/2 inch to 3/4 inch. Dimensions like the OD and the thickness to be referred from ASME B36.10. The material of the pipe is ASTM A106 grade B. What are the ends of the pipe? It is plain ends and it is seamless. What is the schedule of the pipe? It is S160. Now, how we have arrived at this thickness? There is one formula given in the code ASME B31.3. Accordingly, we calculate the thickness, which is based on the design temperature, design pressure, and the material. Yeah, I cannot show you the calculation at this moment because it will take a long time. This is just an overview session. So, and then from 1 inch to 1.5 inch, the thickness changes to excess. Yeah, just for the quick, I can show you the standard. Yeah. So this is the 36.10 standard. In this standard, let us take this case of what we are looking. Here, 1 inch to 1.5 inch excess is mentioned. Now, can you tell me what is the mm thickness of this pipe? Just by looking this excess, STD, S160, no. Then its thickness are given in this standard, 36.10. If you see this is a dimensional standard. It means this standard will give you the details of the dimensions. So let us take this one case, 1 inch excess. It means 1 inch XS. So this connection or the how it is prepared, or that it should be also taken care that it should be easily available in the market. Yeah, just like when you buy a car, 4-wheeler, then you always check what is how is the service, how is the after servicing after buying, how is the servicing of that car can be done. Are the service centers available near to your house, or they are there are enough service centers, as well as if you require any part to be changed of your car, then is that part easily available in the market if you want to buy it, you know. So similarly, when we decide such items, we also have to check whether it is available in the market easily or not. Yeah. So for the till 14 inch, generally it is said that we will go for the seamless pipe. 14 inch and above, we go for the welded pipe. Welded pipe, it means not weld of the connection, but the construction of the pipe. When the pipe manufacture the pipe in his shop, then how it is prepared by the seamless method or the welded method. So when your pipe is welded, your ASTM material changes. Then it is ASTM A672. Yeah. Then we here mention the grade B. Similarly, we have grade B60. Also, we have class 12. Then this class 12 specifies some radiography requirement of that weld. The weld which is done to produce that pipe. Longitudinal weld, I will say. So just to show you one figure. Yeah. So if you see here on a pipe, can you see this weld? So this weld also needs to be checked for its quality. Yeah. And it is defined as per the class 12. So for the bigger sizes, we will go for the welded pipes, like 16 inch to 36 inch. Okay. Then we have another piping component, which is a flange. So here we have different type of flanges available. We have socket level flange. For the small size, sometimes we use socket level flange. So here they have used weld leg flange. So half to 24 inch weld leg flange. Now, as we have seen the dimensions of the pipe in standard B36.10, for flange, we use ASME B16.5 standard. The material for the pipe is A106, but for the flange, carbon steel, it is A105. Yeah. So how flange is defined? Flange. Then what is this type? Weld leg flange. Size range. Standard. What is the material? Yeah. Obviously, we require the thickness also to match with this pipe, but it must be given this code. Then for the bigger sizes, about 24 inch, the 16.5 standard cover. Yeah. So we have this session which covers main topic of the piping material engineer, in which we will explain, not only explain, we will teach how to prepare the PMS, how to prepare the VMS, what are the different piping components, what are different small details of the component, like the small like how to select the rating, how to rate the PT rating chart, how to calculate the wall thickness calculation, internal pressure calculation, the branch calculation, paddle blank calculation, and also some requirements which you have mentioned, like the PWST, radiography, impact testing. The overall requirement we will highlight. And in the course, if you want to know anything more, if you have any topics which are not covered by us, and if you propose, and if we can deliver knowledge on that, then we will include those topics also. So we have this course enroll. So if you want to enroll for this course, you can contact our marketing team. It's available on our website also. And we are planning to start this batch from the next month.
Sir, just I want to know about, yesterday actually I enrolled one courses from the Udemy. And I purchased also, but there is nothing response by mail or by something, and already deducted from my account payment. So how we will reconnect with them?
Okay, so actually I am the trainer. Actually, I am not handling the marketing part.
Okay.
But I have noted your point. May I know your name so that I can convert your market name? Okay, I will just Okay, I have noted your point, and maybe our marketing team will connect with you.
Okay, sir. Okay, thank you so much.
Any other questions? Yeah, sometimes it is 1.5 mm, sometimes it is 1.6 mm.
Okay.
So it depends from the licensor actually.
Mm-hmm.
The corrosion allowance value comes from the licensor.
Mm-hmm.